Hello everybody and welcome back to your computer science tutorial. This is section 3 video 2 and we have a very good joke for today, and it's a blind man walks into a bar and he hits himself because it was a metal bar, you know, like a pole or something like that. Well, that brings up a very good question in the computer science world and 3 dimensions. One, he's a blind man, so how does he know where he's walking? Well, you can actually make it so you could give a player, you could actually make a player blind, and you could still allow him to transverse the world by doing something known as raycasting. Now, you're probably wondering, well, what's a raycast? Well, what a raycast is, it's drawing lines, but in a very specific way. For instance, you can draw lines in a direction to see if something's in front of you. You could draw a line between two objects to see if there's an obstacle in between you, and things like that. This is very useful because, well, with this, we do a lot of investigation into the world around us, and it's also used for more high level code, especially in pathfinding code. You can actually use raycasting to determine a lot of things about the world around you, because by raycasting, you basically can probe the environment to find specific amounts of information. So we're going to jump into Unity now, and I'm just going to do some very basic raycasting. We're not probing the environment to make a pathfinding system. We're just exploring the basics. Okay, so right now I have this little world right here. You got a cube right here. We have a cube. We have a first-person controller, and let me just delete that for a second. Okay, so this is what you should have, and we have our main camera here now. So we have this cube, but we can see that the cube is there. But let's say if we turned off our camera, we couldn't tell. However, this object, if you look in the scene view, this object still exists in 3D space. I can't see it, but it's there. And if I were to move, well, I couldn't tell I wasn't moving, but we need some way to figure out that there's an object in front of us. So I'm going to turn the camera back on, because we have to figure out how we're going to detect this cube in front of us. So we're going to make a script, and we're going to call it a detection script, just like that. And let's open our detection script up, and it's chugging. And here we are. I think I opened 2. Okay, so here's our script right here, and the first thing we want to think is that, well, if you draw any line farther enough, eventually you're going to hit something. So let's put a distance limit on our rake, and we'll call this variable distance. We'll call it dist, and we'll save it as a float. And for starts, let's keep it at 5. Now, first we don't want them to always know something. We want them to be able to click a button to discover something, because what's more interesting than clicking a button and figuring out what's in front of you in a game? Okay, so we have our if statement. Now we need if input dot, let's say the I don't know, let's say our E key. No, let's say our Q key. So if you have Q down, we're gonna create a raycast. But now an interesting thing comes about. In 3D space, well, on the screen you see, well, there's this thing in front of me, so that's what I want to hit. But in 3D space, if I'm in any rotation like this, how do I know where to go? Well, we need to figure out a direction that is that we have to discover where this cube is. So we can't just check everything around us. That wouldn't make much sense. So what we need to do now is we need to figure out a way to say from here to here. Now, this is something a little new, we're introducing a new class, and this class is going to be called it's the camera class. And so let's make a variable, and it's going to be a direction, and we can save a direction as a vector3. At least in this case we can. And it's going to equal something known as camera dot main dot transform dot forward. And what basically the camera class is every camera in the game. It's like a general idea. Like this is a camera right here, this class. And the forward from this camera, which is the main camera, would be just in front of it, which would be the cube. So this gives us direction straight out in the middle of our screen from the camera, which we can use to now raycast. So now, making a raycast, you never make a raycast. Oh, and one more thing. We need a spot to save the information that we get from our raycast. So we'll call this hit, a variable called hit, and we're going to save it as a special variable type called raycast hit, surprisingly. And just leave that variable blank. We're going to fill it with data now. So now, what you do is we got to make an if statement. Every raycast, you have an if statement. And typically from... Oh, that's my dog. Hopefully he's gone. Okay, if you're still here, I'm sorry. So every raycast comes in an if statement because that's just how it works. And so what you need to do is that we need to reference the physics class, and inside the physics class there's a function called raycast. And if you click this, you see on my screen there's a bunch of different ways of doing a raycast. This is the way we're going to be using. It takes we're going to use a one a little more complicated. This is the most basic though. It takes an origin where you want to start the raycast, and a direction and how far you want it to go. That's the most basic raycast. But we want to get some information back from it, not to see that. Is this one it? No, this takes array, and we could reference array from the camera class. However, we're going to do it the old-fashioned way, and just, I think it's this one. Yes, it looks like it's around here. Maybe this one. I don't know. It's this one. Okay. This is... I feel like I already did this one. Whatever. But moving on. So first we need a location, an origin to start out from. And you could go to the Unity manual also if you can't remember these like raycasting. I showed vector, distance, things like those. You can always go back to the manual to see what you can get. But first we need an origin, and it's going to be right where we are, so it's not moving because this is inside the camera. So position. Then we need a direction. Well, we already figured out a direction, so we could just shove direction in there. And a place to store the information, which is a reference to a raycast hit object. And then we need a distance, and we have distance on the outside of our class. And let's close off our parentheses. And now, well, we want to figure out something. So let's say we want to figure out the name of this object. We'll say name of this object is, and we'll just concatenate hit dot collider. This is just the path you have to use to get around to getting to the name. Collider dot name might exist. Yeah, collider dot name exists, but I always go to game object. It's more references, but it's easier to read because you know what you're referencing. You're referencing then, and then just end that with a semicolon, and we're gonna save that script, and it's gonna compile. Let's see if I made a mistake. There's our distance. So now if we run our game and we look at our little wall there, and you see, boom, right down at the bottom, the name of this object is cube. And you'll see I have it on this list on collapse now because I don't like having thousands of debug logs. If it's not, you'll see a long list. I always keep it on collapsed. And we can go to other objects too. We can figure out the terrain. If we look down far enough, you'll actually intersect the first-person controller, which is interesting. These are all named cube. So, but yeah, that's basically it. It's gonna go through trees, I believe. Yeah, because the tree, I can slide through it. It doesn't have a collider, so that means that raycasts don't work on it. So just remember, raycasts only work on colliders, or on objects with colliders, because otherwise, well, it wouldn't make much sense. Okay, so let's see. Well, you might think, well, what if I'm like doing this backwards and I'm not detecting my object? But how would I ever know? Because other than this like thing that says I hit it, there's no other way of referencing what's happening in the editor. So what we can do is that we can actually draw this ray on the screen. So we're going to type in debug.log, and this time we're going to do draw a line. Now, you can draw a line in a direction or between two objects. Never mind, I lied. You can draw it between two objects. Oh, I don't remember how to do ray. I'm not very good with ray. Draw ray. We're gonna do array. Okay, so we need to give this a direction, and we also need to give this a origin. Okay, so transform dot position, not a capital. It always autocorrects. I don't know how to fix that. And we have to give it a direction. It's gonna take a color to show on screen. You reference the color class. You pick any color. Let's pick magenta. And it's also going to ask for a distance. We'll just have dist into it. And let's close that and run it. And it should... This is going to show up in the scene, not the game. FYI. You see, it's a little magenta line. Oh, I see. Because we only have this working inside of the it's not going that far though. They might change because this only works inside when we are hitting something. You actually won't create that line unless you hit something, and I have no clue why. They must change the scale which ray happens, and it just differs, which is why the line's not very long. So if we do draw a line, we could draw it between two objects, which can be useful. It can also be a little less useful too. But so we're taking this position for lines, this position, and we're finding the object that we hit's position. Oh my gosh, this autocorrect is annoying. Dot collider dot game object, and this one you have to go to game object so you can reference the transform inside the game object. Oh god, that is a mouthful. And if I were to close this and save, if we were to run it now it would draw a line in between two objects. If I were to actually run the game, we could look at our scene and Q. Okay, you see it flickers really, really fast. That's because I forgot to add a time. We'll give it a time of 5. I think it's just and a color. So give it color dot. Let's go magenta again. I like magenta. and a time of 5. Let's see if we got that order in right, too. I might have put those in the wrong order. Nope. Well, from what I think, I put them in the right order. Let's see now. And you see, there's my magenta line, and it's always going to go to the center of that game object, no matter where I am. You'll see, terrain is a little weird. The origin of the terrain, I actually can't see it now because looking too far down. If I were to move towards this, and it's difficult to show, but basically the origin of the terrain is way over there, and since this always sends back to the origin of our game object, you'll notice that if I were to hit the if I were to look here, if I were to look at our building over here, and I were to hit here, it's always, no matter where I start from, even if I'm not really looking at it, it's gonna look at the center. So like, even if like I'm here, it's gonna look at the center, and I'm looking. It's hard to show, but I'm not looking at the center, but it'll always raycast to the center of the object. Okay, so that's about it. Yeah. See you guys next time. Next time we have something fun. Oh, I gotta stop this.